Once again, welcome to our Cooled Care Maths class, and today we are going to learn about indices, and if you have any question or any comment, just feel free to type it in the comment section. So, I will start by explaining the anatomy of an index. Given this general form of an index, we have A as the base, which is the number that is being multiplied by itself. Then we have the index n, also known as the exponent or power, which tell us how many times should we use the base in multiplication. For example, if have any number x, which is to the power of 3, it means we multiply x 3 times. Hence, x times x times x. So, if we choose a number like 2 to the power of 3, it means 2 times 2 times 2, which is equal to 8. Now let us move to the laws of indices. The first one is the multiplication law, which states that when multiplying terms with the same base, add the powers. So, if we have a to the power of m and a to the power of n, the result is a to the power of m plus n. For example, given 2 to the power of 3 times 2 to the power of 4, we get 2 to the power of 3 plus 4, which is equal to 2 to the power of 7. The second law is the division law, which states that when dividing terms with the same base, subtract the powers. So if we have a to the power of m divided by a to the power of n, the result is a to the power of m minus n. Take note that the index of the base that is being divided is the one which should subtract the index of the base that is dividing. Let's do an example. Given 3 to the power of 5 divided by 3 to the power of 3, we get 3 to the power of 5 minus 3, and our answer is 3 to the power of 2. Suppose we switch the 2 so that it becomes 3 to the power of 3 divided by 3 to the power of 5. We get 3 to the power of 3 minus 5, and our answer will be 3 to the power of negative 2. Now let us look at the power of a power law. The rule is that when raising a power to another power, you multiply the indices. So, if you are given a to the power of m, which is raised to another power n, the result is a to the power of m times n. I have realized that most people confuse this with multiplication law, so they end up adding the powers instead of multiplying them. If you check in this case with 2 to the power of 3, which is raised to the power of 2, the correct answer is 2 to the power of 6, not 2 to the power of 5. Also, on the same concept of powers, when bases are multiplied together and raised to the same power, you distribute the power to each base. Hence, ab to the power of n is the same as a to the power of n times b to the power of n. So, let me give you an example which combines the two concepts about powers. We are given 3x squared to the power of 3. So, we start by distributing the powers and get 3 to the power of 3 and x squared to the power of 3. We know 3 to the power of 3 is equal to 27, and for x we simply multiply the powers, which is 2 times 3, and it gives us 6. Remember to always apply the power to the coefficient, because most people forget that part. Now, let us look at zero and negative indices. Starting with the zero index. Any non-zero base raised to the power of 0 is 1. So, whatever number that you are given with the power of 0, the answer is always 1. Then for negative indices, a negative power represents a reciprocal, which means we have to put 1 over the base with a positive index on the base. Hence, a to the power of negative n is equal to 1 over a to the power of n. For example, 2 to the power negative 3 is equal to 1 over 2 to the power of 3, which gives us 1 over 8. Now let us look into fractional indices, which introduces us to roots. So, the denominator of a fraction determines the root. Given a to the power of 1 over n, this is equal to the nth root of a. The numerator remains as the power to the base. Hence, if given a to the power of m over n, the result is nth root of a to the power of m. So, you start by finding the root first, then you apply the power. Let me give you 3 examples that you can easily follow through. The first one is 9 to the power of half. This is simply the square root of 9, which is 3. The second one is 8 to the power of 1/3. This is the cube root of 8, which is 2. The last one is 27 to the power of 2/3. For this, we start by finding the cube root of 27 first, which is 3. Then we apply the power of 2 and get 9. Now, lastly, we will discuss about solving exponential equation. This is more like application of the indices that we have been doing. So, we use what we call the same base method. This method states that if we have two terms in an equation with same bases and unknown indices, it means the indices are equal to each other. Suppose we have a to the power of x being equal to a to the power of y. It means x is equal to y. Let us do the example together. We are given an equation 4 to the power x is equal to 32. So, the first step is to make sure that we have same bases, and in this case, the base of 2 is the common base. Now that we have 2 to the power of 2x being equal to 2 to the power of 5, we can then take the indices, or powers only, and equate them. Hence, 2x is equal to 5. If we divide both sides by 2, we get our answer, which is x is equal to 2.5. Thank you so much for watching. I hope this video was very useful to you. And once again, if you have any comment or question, just feel free to type it in the comment section. And don't forget to like, share, and subscribe. I wish you all the best.